Hi everybody, today I want to show you how to create a chatbot with LangChain on Microsoft Azure. I assume that you have watched my introduction to LangChain and also know what Microsoft Azure is, but I will make a little introduction into the services we use. We will use Azure Web App, Blob Storage, Azure Cognitive Search as vector database and Azure Container Registry for a Docker image. This is the result, just a little website that allows a user to chat with a database, all deployed on Azure. You can find the code in the description. Okay, now let's first start with Azure. Azure is Microsoft's cloud computing platform, providing a variety of services ranging from infrastructure as a service, platform as a service, to software as a service. In simple terms, Azure helps you to manage and deploy applications on Microsoft's global network of data centers. Think of an Azure subscription as an agreement with Microsoft to use one or more Microsoft cloud platforms or services. For these services, Microsoft charges you either monthly or pay as you go. It's essentially a billing unit and a way to group resources in Azure. In one subscription, you can have one or more resource groups. A resource group is a container that holds related resources for an Azure solution. The resource group includes those services that you want to manage as a group. Imagine it as a virtual folder where you can group your Azure services. Okay, now for the specific services we use. Azure Web App. Part of Azure Web Services, it provides a platform to host web applications, RESTful APIs and mobile backends. It makes the hosting process simplified without worrying about the infrastructure. You can deploy your application as code or as a Docker container. Blob Storage. Azure Blob Storage is Microsoft's object storage solution for the cloud. Blob Storage is optimized for storing massive amounts of unstructured data, such as text or binary data, which makes it perfect for serving out data for the chatbot. Azure Cognitive Search. This is an AI-powered cloud search service for developing web applications or mobile applications. For our purposes, it acts as a vector database, allowing the chatbot to efficiently search and retrieve information. Azure Container Registry. A managed Docker container registry that makes it easy for developers to store, manage and deploy Docker container images. This is how we store our chatbot's Docker image for deployment. So with these components in hand, we're going to create a seamless chat experience using LangChain on Azure. Stay tuned and I'll walk you through each of the steps. Okay, this is the Azure portal homepage where we will create our resources. To follow along, you should already have a subscription on Azure. We will create everything in the UI, but of course you can also use Azure CLI if you want to. Okay, first we start by creating a resource group. As you can see, I already see this icon here because I used it before, but if you don't see that, just go to the search bar and search for resource groups. Then you click here and here on create, so we can create a new resource group. Okay, and then you have to enter a name. I just call it YouTube resource group. Then you have to select a region here. I will put it in Europe. This is just a data center where the server lives. So after that, click on review and create. And if everything is correct, then it passes the validation and you click on create. So now we can go to the resource group. And as you can see, we don't have any resources in the resource group yet, but we will start with creating a blob storage. Okay, let's go to the search bar again and type in storage. And we first have to create a storage account. There you click on create. Okay, first we have to pick a resource group. We will just pick the resource group we just created. Then type in a name. You can type in whatever you want, but it has to be lowercase and between 3 and 24 characters. YouTube storage account. Okay, that's already taken. Just type in a number. It doesn't really matter here. So let's keep that the standard, and that's all right. So let's validate it and just create the storage account. So inside the storage account, we can create containers now after deploying. That will also take 1 to 3 minutes. Okay, everything worked and we can just go to the resource now. So inside the storage account, we can now create a blob container. A blob container is in hierarchy where you store multiple objects grouped together. So you have one storage account and the storage account can have multiple containers, and every container can have multiple blobs, and one blob is a file like a JPEG or a text file or whatever. Let's create a container. Just click on plus here and we can now call the container whatever we want, and we can say here the access level is private, blob or container. Private is when we need an API key to actually make it work, and this is the most secure way. We will pick that and click on create here. So now we've got our container, and here we can upload files, but of course we don't want that in the UI. We want to make that via Python. So I will show you in the code how that works. Okay, I'm here in the blob.py file. This is where we'll upload the blob from Python. So we've got our data folder, and we have a textdata.txt. This is the file which includes all the information about this fictive animal, a mixture of a rabbit and a chicken. So this is what we want to upload in our blob storage. So we need some information, the connection string. The connection string includes all the public and private information we need to connect from our local system to the Azure portal. And then we also need the container name. This is the name we created before. This is just my container. And we also need the blob name. This was YouTube storage account 123. So let's just use that. YouTube storage account 123. And then we've got a directory path. So this directory path is needed because we loop over each file in this directory path and upload every file which is in that directory. So what's actually going on here is that we create an instance of the blob service client here by providing the correct connection string. And then we will iterate over each of the objects here inside the data directory. And we will get the blob client. This is where we will enter our container name. This is the container name, my container. And then also take the blob object itself, and then just run the upload blob method with this blob client. So that's how that works. And now let's enter the connection string here. So the connection string can be found here in our storage account. This is the same for each container. You will find that in access keys. And then you've got two keys, key 1 and key 2. You can pick whatever you want. Just show the correct connection string, copy that, and then enter it here in VS Code. So that should work now. But before actually running Python blob.py, make sure you've got the requirements file installed. For this operation we need Azure Storage. So I already installed it. So I can just type Python and then blob.py. So as you can see, text data was uploaded correctly. So now if we take a look at the container again, so let's go here to containers, and my container, we can now see the textdata.txt was inserted. Okay, let's continue by creating our cognitive search service. Just search for cognitive search and then create a new service. Put it inside the correct resource group, enter a service name. And then put it inside the correct location. And here, very important, you have to change the pricing tier. This can be quite expensive if you stick to the normal one, which is $250 per month, so be very careful here. Pick the free one. You can create up to 3 indexes here. Just review and create it. And validation was successful. Click on create and then wait for the deployment. This again will take some time, but yeah, pick a coffee if you want to. We will just continue here. Okay, everything worked. We now got our vector database, and here we can create an index. We could import data, use the search explorer and so on, but we will use the Python SDK to actually insert the correct data. So let's go to the code and see how you can actually create the index by getting data from the blob storage. So I'm here in the Azure Cognitive Search.py now, and as you can see, we import some classes here like the OpenAI embeddings, which will be responsible for creating our embeddings in the vector store, then Azure Search and Azure Blob Storage Container Loader. This is the loader we will use to actually load our data, and then the character text splitter to actually create chunks from our txt file. So First, we will create a vector store address. So we will have to provide the Azure Cognitive Search service name here, and this will create the correct address here. Then we will create an instance of the embeddings, use our model here. This will be text embedding ADA 002. We also create an instance here of Azure Search. This is from LangChain. And here we have to provide the vector store address and also the Azure Search key. This key has to be retrieved from the UI. Then the index name we will just say our index name will be LangChain vector demo. We can pick that on our own. It will be created with the SDK. And then we also have to provide the embeddings function to actually create the embeddings. For our data, we use the Azure Blob Storage container loader. We have to provide the connection string here, which is stored in an environment file, and also the container name, which is my container. So we have to put that inside the .env file to make this file work. So after that, we will load the documents, split the documents, and then upload the documents to the vector store. Okay, I forgot something here. Because we use that file locally, we have to import from .env, load.env, and run that function to actually load the environment variables here from our .env file. So let's have a look at the .env file. As you can see here, we need an OpenAI API key for the embeddings, and we also need the Azure Cognitive Search service name. So this is just this part of the URL. This is the service name. You can just copy that from the URL and input it here. Then we have to provide the correct index name, which we provided here as a string, LangChain vector demo. And then we have to provide the Azure Cognitive Search API key. You can get that API key here, go to keys, and then just copy one of the keys, the primary key or the secondary admin key. I just copy that key and put it here. And this connection string is for the blob container, so we can just copy that connection string from the blob.py file and then just put it here in the .env file. Okay, so we have to create a string here because there are escape characters here. You can see the semicolon, so we have to use a string to make that work. And now the container name is my container. This is what we also created on our own. Okay, this should work now. Let's try it out. So I'm sorry, before running it, you have to fix a little error. I put that string symbol here at the wrong part. You have to put it here. Otherwise it will not create the correct connection string. So let's try it out now. Azure Cognitive Search.py. And hopefully that will work now. Yes, we can see that the chunk creation worked and the data was loaded into the vector store successfully. Let's now have a look at our cognitive search index. You can go to indexes here, and here you can see the LangChain vector demo. We click on search here just to check if our embeddings were created. Yeah, we can see the content was created and the content vector was also created. Fine, that works. So we can now use that vector store to actually retrieve the information from our chatbot. And don't let you fool by the document store. As you can see, when I click on refresh, I can see I've got 14 documents, and also that the storage here is 368 kilobytes. So just click refresh and you should see the documents. Okay, let's go to the VS Code file again. Here is the application.py. I will just walk you through the code a little bit. As you can see, this is a Streamlit application, and we also use some retriever objects. We use the Azure Cognitive Search retriever. We use the conversation retrieval chain, which makes use of a vector store. And we also use the conversation buffer memory to actually store the history of our chat in memory. Inside the code here, we will create a memory object here with conversation buffer memory, and then create a function called load chain. This should initially load our chain with a prompt template. You're a helpful assistant for questions about the fictive animal Huninchen. We provide a context variable here, which is for the information from the vector store, and also the question itself. So we pass that to a prompt template, context and question here as variables, and then we create a retriever object. This is the Azure Cognitive Search Retriever, and we take the top 10 documents from the vector store. Then we will create a chain, the conversational retrieval chain. We use ChatOpenAI as our model. We use the memory and also use the retriever here. And we also pass in that prompt as keyword arguments. So this is the chain we want to return from this method. So we call the function. This is now our chain, and this will be used then in the text. Okay, everything below this chain object is just a Streamlit code and responsible for creating our UI. So we store everything of our conversation in the session state. We will also provide a text input field where we can type in the text and then display everything in the UI. So this is the code here. It's more or less just boilerplate code for a chat application. So let's just take that. We can use that code now to create a Docker container with it. And we will use Python 3.11. You can see it's actually quite easy. We copy everything in this app directory, which is the working directory, then run pip install the requirements.txt dependencies, and as cmd startup command for our application, we run streamlit run application.py, use port 80 because that's the default port for Azure Web Service. And here we have to pass in also the server address 0000, which is necessary if we containerize an application and want to access it from outside the container. To use a Docker image on Azure, we have to provide some kind of registry, which is responsible for holding all of our images. And this can be Docker Hub, for example, but it can be also an Azure service, which is container registry. Let's search that. It's here, container registries. Here it is on the right. And now we can create a new registry. We also put it again in the right resource group and just call it YouTube Azure Registry. Okay. So this gets another URL .azure.cr.io, and then important, use the basic SKU. This is very cheap and provides enough storage here. So let's create it. Okay, everything worked. Let's go to the resource. As you can see, we can use up to 10 gigabytes. Currently we used 0. And now we can use that to build our image and push it here in this registry. To be able to push an image to this registry, we have to log into this registry. If we use the Docker CLI at least, we could also use Azure CLI, but that's a different topic. So we have to toggle in this admin user. So we get an admin user and we also get a password. We have to use that. So to log in with Docker, we have to use the login server first. So let's copy that. And here, just check that you've Docker installed. I use Docker PS. As you can see, this works. So if that works for you too, you should be fine. And then use Docker login, the login server, then -- username. Then we have to provide the username here. The username is this, and then -- password, and then you have to use one of the two passwords here. Okay, you can see we've got this is insecure, but for our purpose it's fine. You normally should use Azure CLI, but yeah, it's a little bit more complex, so for this purpose it's fine. And we are now logged in, so we can now build and push our image. Okay, let's now build our image. You normally would build an image like this, docker build -t for the name, then the name would be app, and then you provide the folder with a dot, so it searches on the current directory for a Docker file. But in this case, we have to provide also the registry. So we have to use it like this, copy that, and then put it in front of app, then use a slash, and then behind this name of the app, you have to provide colons and then the name of the version. We can just say the version tag should be v1 for version 1, and then just build it here. Okay, so this will take some time to install the requirements and everything. So let's wait for that to finish. Okay, everything was built correctly. And now we can just update the command a little bit. And instead of build, we just use push. You can use here the name of the registry, then the name of the app, and then the version. So let's push it, and this will take a little bit more time because you actually have to upload everything in the registry. So wait a few minutes. I would say it takes up to 5 minutes to make that work. Okay, everything was pushed correctly in the registry. We can now create a web app service to actually make that image run as a container. Okay, now let's go to the portal again and search here for web app. And here you can see app services. So create a new one, create a web app. And then we have to use our resource group again, select a name. This will be part of the URL, so that is normally quite important. But yeah, not for the showcase here. Your web app 1, 2, 3, 4. And then select Docker container here because we want to take that from the Docker registry. Use West Europe or wherever you are from. Important here, it should have a free plan, and then everything is fine. In the second tab here, you have to go to Docker, and we use a single container. And as image source, we could use Docker Hub, but we can also use the Azure Container Registry. So we have to take it, and this is our registry, YouTube Azure Registry. We've got a single app, and we've got a single tag. This is the latest tag. We could provide a startup command, but if we don't provide a startup command, it will just take the startup command from the Docker file. So we'll be able to override it, but we don't have to. So let's create it. And then we again have to wait a little bit. And at the end, we should be able to visit our website with our chatbot. Okay, our resource was created. Let's go to our resource and then make a right click here and open it in a new tab. This will normally take some time. We can just go to log stream here to see if everything works as expected or not. So this is still connecting. Let's wait a little bit more. And now we are connected to the stream, and we should see in a few seconds if everything normally starts as expected. Okay, as you can see, this did not work, and the reason is because we did not provide the correct environment variables. So when we develop locally, we would normally just use from.env and then the load.env method, and then it will load all environment variables here from the .env file. In Azure, it doesn't work this way. We could normally also copy that just inside the Docker file here, but I put it here in the Docker ignore because you don't want to include some environment variables or secrets inside the Docker container itself. That makes it unsecure, but we can make it differently. We can go to the service here and then go to configuration. It is here, just below settings. Here is configuration, and inside the configuration, there you can see we've got environment variables. So we have to add them, and we can just add them one by one, just add the name and the value, but it's actually easier if we go to advanced edit. And as you can see, this is a JSON object, and I already provided this env example JSON file. As you can see here, we don't have any values yet, but we can just copy the values from the .env file and set it here. So we can just copy that JSON file just into Azure. Okay, let's copy that. So every value here, just go here, and we need a comma here, then just paste it, set it to OK, and then go to save. So this should now include the new variables here. Everything worked, as you can see. So let's go to overview again, and then just restart our application. So that worked again. Let's go to log stream, and now let's check if everything works as expected with our new environment variables. As you can see here, the logs do not get lost if you restart the application, but we start again with a new log stream. So And yeah, I think we can already see that this works now. And we can type in, what does a Huninchen eat? And we should now get back some information from our vector store. Yeah, it primarily feeds a combination of plant matter and small insects. Yeah, that works. And as you can see, this is the way we can deploy a web application on Azure with a custom vector database, and everything, all the information is backed up by a blob storage. And we also created a Docker image and stored that into a Docker registry on Azure. So yeah, that's it. That's our application. If you've got questions, feel free to write them in the comments. And if you liked the video, feel free to subscribe to my channel and give the video a thumb up. Thank you very much. Bye bye. See you.